Welcome to Math. So in this video we are going to see the modification of trigonometric function when we are making particularly the vertical shift. And you can see we start with the two question. And before going to plot y equal to sine x plus 2, I would like to draw the y or plot y equal to sine x to remind you, and then also to see then how actually the graph changed from the original graph, which is y equal to sine x. If you look at that two function, you can see our amplitude is both same, which is 1 and 1. So we can plot the graph like, that this is our amplitude 1 and in the other direction is a negative 1. Okay. But here our period is also same, which is our b is 1. If you look at and compare to the general form, b is 1, so it means our period, the degree completed for whole circle, so degree takes to complete the whole circle, it is twice pi. So, and you know that this is our pi over 2, and each critical distances would be the pi over 2, so it would be just pi, then 3 pi over 2. All right, so this would be our scaling now, and that it will take 2 pi to complete the whole circle in both cases, because our period not changing here, only the vertical shift. But before we draw that the one y equal to sine x plus 1, I would like to draw the y equal to sine x, and then you can see the difference between these two graphs. And the graph is just coming like that, the sine x, and we already are familiar with the sine graph, so it is coming like that, and then it will be like that, right? And then it will be like that. So that's our sine graph. Now we are looking at our y equal to sine x plus 1, and for that, that plus 1 is a vertical shift, so it means our graph will start from plus 1. Our axis is shifted up, so our x-axis moved up. So when you are looking at the plus 1, if the equation come with the plus 1, it's a shift up by 1. So actually the x-axis moved up by 1, and then where the graph will be, because amplitude is still same, so it means if the graph start from here, you have to understand that it will go up by 1 and down by 1, because our amplitude is not changing, but it is starting, instead of here from 0, it's starting from 1. So in order to do that, also sometimes it's better to do that calculation, what is the upper limit of this new graph and what is the lower limit. For doing the upper limit, you can use that vertical shift minus sorry, for upper limit, vertical shift plus your amplitude, which is 1, which is giving you 2, and then for lower limit, again your vertical shift minus your amplitude, which is 0. So it means, from this calculation, the graph, the lower part will be in this, so it means in the x-axis or in the 0 value, and then upper limit will be at 2. So that's the so we know the graph will move within this part, so 2 to 0. So that's our upper limit and lower limit, that's the range of the graph. Now if I start, and we have to start from here instead of 0, so it's shifted up. So graph, you can see if I draw it, and then still it will go up by 1, then coming down to 0, and then coming down to negative 1, so in that case it's 0, and then it is coming to 0. But 0 is like, it means it's just 1, so it is coming to the central point. So for this new graph, our central point is y equal to 1, right? So it means the graph central axis is that color, new color. So just, and then we are just plotting the same sine graph anyway, so like that, and then it is coming to here, and then it's going to there. So if you look at the graph, it's pretty much the same. Yeah, and then you see that the gap is always the same. You can see the gap everywhere, the gap would be the same, it's just 1, because the graph is just shifted by 1 in everywhere. And even if you extend the graph, you will get the same thing. So if I extend in the other side, like in the negative side, or even after the next period, so from 2 pi to 4 pi, you will see the same pattern. So if I just show you, this is our y equal to sine x plus 1, and the black color graph is our y equal to just sine x graph. So I'm just showing both in one graph to see how the graph moves for changing the vertical shift. Okay, let's do the another example, which is y equal to 3 cos x over 2 minus 2. Here you can see our amplitude is 1. So if I just write down the notes, which is our amplitude is 1, so you can just copy here probably. Amplitude is, sorry, in this case the amplitude is 3, obviously you can see amplitude is 3. And then our period, so period is 2i pi over the value whatever here is half, which is giving us 4 pi. That's our period in this case. And then what we have the vertical shift, which is d equal to -2. So when I'm saying the vertical shift -2, it means the graph, the starting point will be 2 down. So the vertical should be -2, it will be just -1, that's -2. It means your x-axis is shifted down in this case. Okay, so this is your new axis or reference axis now. So we are our the graph center will be this axis now, no more x-axis. Okay, so I'm doing upper limit. I can just write upper limit you all. Vertical shift plus amplitude, which is +1, and for lower limit, just in case I'm just writing lower limit or lower part, I can just write down lower. This -2 is the vertical shift, -3, which is -5. Okay, doing this calculation is really better to do first, because then you know how to draw the graph. So I know that our lower limit will be -5. That's why my graph, I'm just putting the top upper part is less, because we know that graph is going up to -5. So this is -3, -4, -5. So that's, so our lower limit will be up to -5. That's why I plot the graph, because we don't need much on the upside. Upper side would be only up to 1. So it means the graph will be until coming up to 1. That's the lower part, and then the sorry, upper part, and the lower part would be -5, and the central part would be -2. That's, we know it's from the vertical shift. Our what's called our period is 4 pi. So if I just break that 4 pi again, for one complete circle we have 4 critical point, we know that, and that is 4 pi. We know one complete circle will be completed in 4 pi, and then we know that this would be just pi, 1/4 of 4 pi, right? And this is half of it, which is 2 pi, and this is just 3 pi, right? So pi, 2 pi, 3 pi, 4 pi. In this case, every critical point is just 180-degree gap. And now the graph start always from the top for the cos, we know that, and it's a positive obviously. So it's starting from the +1, and then it is coming to 0, right, at in the first quadrant, and then it's coming to here, and then at 2 pi it will be the lowest value, which is -5, right? And then at 3 pi it will be 0 again, right? So in this case -2 is the that axis position, and then it coming back to the axis, and then it going to the, like, it's a central axis, and then it's going to the maximum value. So now we just need to draw the graph. So it just, you know that it is just coming like that. So you can make it a little bit sharper here, and then go, and then going up. Yep. So that's the cos graph. You can see the original cos graph look like that. In this case, just a bit elongated because our amplitude is 3. And you can see the period change. Instead of 2 pi, it's now the period is 4 pi to complete the whole circle.